Okay, so we talked about how to synthesize an LC driving point impedance function or driving point function. Till last lecture, we didn't used to get the unique answer. So for getting the unique answer, we got four different methods, which are known as Foster 1, Foster 2, Coir 1, and Coir 2. So when you are drawing Foster 1, are they in series or in parallel? Yes, Aman? Are they in series or in parallel? Series. So this kind of thing is also known as Foster series technique. And Foster 2, it's in parallel, that's why it's known as Foster parallel or Foster shunt. This is used for impedance function and this is used for admittance function. And Coir 1 and Coir 2 this is like invented name by myself, so do not consider that one as more general name. But Coir 1 I call LC and Coir 2 I call CL, because when we are drawing the Coir 1 and Coir 2, they are going to give me the first element in Coir 1 is L, second element is capacitor, and in the case of Coir 2, first element is capacitor, second element is inductor, and so on. Right? To solve Foster 1 and Foster 2, you have to follow partial fraction method. For this case, what do you think? What should be the thing? Continuum fraction. Right. So when you are doing this in first method, I found out, if let's assume that there is a function which is given and look like this one. Okay, so now I want to find out can you find out K1 and K2? It's a mathematical problem, right? It's mathematics. So how do you find out K1, by the way? Yeah, use your technique. Look, I have not taught anything else. Whichever technique is known to you, please follow that and find out K1 and K2. 10, 10. Okay. How did you find out this? Okay, so you just manage it. Okay. Now, yeah, so what is going on? Okay, so now are you able to manage to find out these things, or maybe if you like you can do this one also. Okay, it has to be divided, right? So are you getting any difficulty, or so now tell me, you are, so you are like some mathematician who knows everything, that's why you are not using your pen. Yeah, I'm talking to you. So tell me K1, K2, K3. Ani like this is a very simple question, right? Not so much complicated. I'm just asking, and I want to know what technique you are using to find out K1, K2, K3. Yeah, Manpreet, did you get some answer? Okay, so if you don't know, then I'll teach you some technique which is known as residue theorem. And I'm not going into the proof. If you are interested in proof, please go through some mathematics book in which you have to follow Cauchy's theorem. Or so residue theorem has been derived from Cauchy's theorem, or you can use some of the Strom's theorem, Parseval theorem, all the connection of this, which is used for contour integration, right? So the conclusive remark of Cauchy's theorem says that if I want to find out residue, first of all, we know what is residue. If this is k1 divided by s plus k2 divided by s plus 1 and plus k3 divided by s plus 128, then what I need to find out, I need to find out k1, k2 and k3, which are known as various residues. But k1 is defined as a residue at s equal to 0, k2 is defined as a residue at s equal to minus 1, and k3 is defined as a residue at s equal to minus 128, right? Okay, and if I want to find out k1, at that time I'll forget about k2, k3 or other rest of the things. Let's forget about these people. So I'm left with f of s equal to k1 divided by s. So s will go that side, so that will give me s times f of s when s equal to 0. This is the residue theorem, or you can write down in a different way. Limit s tends to 0, s times f of s. Can you find out k1 very quickly now? Hmm? Square. Square, okay. Is it correct? Similarly, if I want to find out k2, k2 is nothing but s plus 1 times f of s at s equal to minus 1. If there is a mathematical mistake, please correct it. Okay. So I am not solving this. You people have to solve and you have to tell me. Yeah, now tell me. Hmm? नीचे 0 नहीं, you have to keep s equal to minus 1 because I am finding out denominate. I have to multiply this by s plus 1 if I want to find out residue at s equal to minus 1. If you look at this equation, f of s is the complete equation. So s plus 1 will go. Rest of the things you have to substitute s equal to minus 1 and you have to find out the value. Hmm? Yes, Aishwarya? 1280. Okay. Give me the final answer. Hmm. 20 multiplied by 128. Oh, okay, okay, okay. This is not so much important, so that's why. Okay. Okay, so you know the answer, right? It's just mathematics. You have to follow that. You have to substitute your value in your calculator, and you will get the answer. Or right, you can solve this. Now, what about K3? Somebody can tell me the equation for K3, by the way. Like I have written here. What is the equation of K3? S plus 128. Yeah, as Gaurav is saying, limit s tends to minus 128 multiplied by f of s, right? So you can find out all these values by k1, k2, k3. But if they are simple, there is no problem. Look, this theorem is useful when it is something like if it is something like this. So then if I want to find out the residue, which are two residues are available at one place, so multiple residues are there, so then you have to do following thing. So as per residue theorem, it says that if this is k1 divided by s plus, it will not be only k2 but it will be k2 times s divided by s plus 1 square. It will not be just k2, you have to multiply with s, or the lower value 2 minus 1, that has to be kept here. This must be known to you, right? K2s. Okay. But I combine everything and I call this one as K3, K2. This is also possible. It will give same answer. This way also I can find out where K2 will be combination of K2 plus K3, right? So if this is the case, and if I want to finding the residues at 0 is very easy, right? So K1 is equal to limit s tends to 0, s times f of s, right? But K2 is equal to limit s tends to minus 1, but the value here which is coming, it will be derivative of, so this n is the order, so order of this one is 2, so I am going to keep here 2 of f of s. But when we are doing this, we have to make sure that it will be 1 by n minus 1 factorial has to be added. So this follows Lorentz series, and through that Cauchy has derived this, which is known as residue at, like multiple residues are available at one point, then you have to follow this equation, right? So this is residue theorem. If you have 3, if you have 4, you can solve any number of residues, right? If there are multiple residues are at single point, right? Okay, so this is normal technique. But if I am interested in finding out the LC driving point function in the form of, let's say, K0, K2, K4, I'm writing K2, K4 like all the even terms, because its LC function is the one where even by odd or maybe odd by even functions we will have, right? If you remember, we have derived this by this positive real function technique. Last time we already derived that it has to be even by odd or odd by even, and the poles and zeros are interlaced. If this is the case, then it's LC function, otherwise it's not there, right? So if it is LC function, which can be written in the form of like partial fraction, so k0 divided by s plus 2k2s divided by s square, and so on. You may have like 6th order, 8th order or 10th order system, or maybe higher than that one. Then you have to use, maybe residue theorem might be one technique. If you think it's faster, use it, otherwise it's not required, right? So if that is the case, then you can find out k0, k2 and other things. If I want to find out k0, can you tell me what will be the value k0 for this equation? Right? Similarly, if I am interested in finding out 2k2, let's call this one as k2, which is combination of both, or let's call this one as k2 prime. What will be the k2 prime? Can I write this, right? So this is also another way, or when you are doing this, you will get same answer. So Cauchy's theorems, like he has derived one corollary where you have to write down if this is the function. Through that, he told that k2 is nothing but s divided by s plus 1 square times f of s at s equal to minus 1. This will also give the same answer, right? So there is no need to go to derivative on all. If you go through derivative, it will give same answer. I checked and it works. So you can find out k0 is equal to s times f of s at s equal to 0. You can find out k2 prime, which is 2k2, is equal to s square plus omega 2 square divided by s times f of s at s square equal to minus omega 2 square, and so on. And k infinity is equal to f of s divided by s at s equal to infinity, right? Because here it's a 0, availability of 0 at infinity means at infinity you will have pole, right? So in that case you can draw the circuit. Drawing the circuit we practiced last time, so I believe people can draw this one, right? Okay, so now let's assume the case which looks like this one. I want to derive the circuit which is Foster 1. Foster 1 circuit is the one which is also known as series, Foster series circuit, or it's synthesizing Z of s. So Z of s is already given to you. It has third order system and numerator has fourth order. So it means that you should have some 0 at origin or some value. You should have 0 at origin plus rest of the things, where numerator order and denominator order will be same. Okay. Okay, I should write down this 0 at origin, and here you will have rest of the things. Here the order will be 3 only, or you should not worry about it, because I can rewrite this as right. Now I want to find out k1. Can you help me in finding out k1? What is the value of k1? So find out the final value. Something will be coming, 9 by 2, 9 15 by 2, or something will be coming, right? Yeah, Gaurav, are you following, or somebody who does not follow? Akshat, are you following till now? So k1 is equal to s times z of s, where s equal to 0. I am doing it at last. 0 at origin is equal to something like this. We'll do it last for some different reason. No, we made it like 3 different partial fraction, right? 1, 2, 3. You're going through the common sense. This will work for sure. Give me the answer. 9 by 2. What about k2? 12. Okay, is it correct? 12? Because 12 is unfamiliar answer to me, which is given in the book. That's why I'm asking. Please recheck. Answer is 15 by 2, by the way. You should get 15 by 2. We'll do it last. Yes, it's equal to pole at infinity. You're right. I wanted to tell that at end. That's why. So if it is pole at infinity, then you can find out k0 is equal to. Can you write down the equation? So limit s tends to infinity, 1 by s times z of s. Which one? K2 or K2 or K0? Which K2 is equal to 15 by 2. Look, if you are seeing something called minus, and if z of s is already positive real function, then you are making some mistake, right? If this is minus, then this might not be positive real function, but this is positive real function. Yeah, it has to be positive, right? Please recheck what you are doing, right? If you are seeing somewhere minus answer, means this function has to be not positive real function. So that's not a good thing, right? You have to stop yourself there itself. Yeah. So what about this one? K0. 0 or I guess if in case you are getting somewhere 0 by 0 or infinity by infinity, then you have to use L'Hopital, right? Or what do you call? L'Hospital or L'Hopital? In French, it's called L'Hopital, right? Some people are calling that. That's why I'm telling you. So I don't know. It depends on who taught you, right? Hmm. Two, two R, two. Okay, okay. Right. No, like I'm not replacing at s equal to 0. Z, you may have two things. If you look at the reactance curves, in reactance curve, if there is 0 at origin, it means you will have pole at infinity for the same function. And if you have pole at origin, you will have 0 at infinity. We want to avoid the use of L'Hopital. That's why we are doing this. Otherwise, maybe you will end up with 0 by 0 or infinity by infinity, right? So if you are keeping the limits and if you are getting something called 0 by 0 or infinity by infinity, then you have to follow L'Hopital, right? So there might be case sometimes, but I believe in LC function you should not see 0 by 0 or infinity by infinity. You can solve without it. Yeah. To avoid that we are doing this. Otherwise you can always keep 0 equal to uh, origin. That is also possible thing. Right? So is there any problem till reaching here? Is there anybody who has problem to reach here? S square equal to minus 4 we are keeping. Look, it's coming on simple simple poles. Even I yesterday I read about, like, I was reading some mathematics book. Which book you are reading, by the way? I was reading Crazy. Have you gone through which book you are following? So I was reading Crazy and I found out if there is, so that book has written simple pole or simple is equal to if the poles are coming on j omega axis and there is no real part. It's already defined in mathematics. Okay, so if you forgot, or maybe your professor must have taught you but you forgot that, then simple is equal to when it's coming on j omega and there is no real part, right? So it has to be there. It might be s square equal to minus 4 is means your poles are on j omega axis, because we always want causal system, right? That is the like first agreement at the beginning of the chapter, that we are going to follow only the we are going to solve all the systems which are causal if they are Non-causal will not do that. Sorry? If it is this side, then you cannot synthesize using LC. You can synthesize with RLC or maybe RC or RL. But as a limitation of this course, we are not studying RLC. We are studying only RC, RL and LC. The first topic is LC, where there is no real part. If there is real part, it's resistance, and if there is just reactance part, so that is also the reason why we call all these curves as reactance curve, not resonance curve. So in RC and RL, you are going to replace that name with resonance curve, because there is some real part will also be there. So all good, Nikita, till here? Okay. So now, can somebody help me in drawing this? Because now we reach the final answer. We have to just replace the inductor capacitor values. Aman, do you want to try this time, or do you want to try this time? Okay, you can try in your notebook. So first one is inductor or capacitor, by the way. Inductor with value of 2 Henry, right? The unit of this one is ohm, unit of this one is ohm, unit of this one is ohm. Of all ohms are coming in like with the plus sign, means they have to be in series. That's why we are solving Foster series technique, right? So now, so what do you think about this function? Is it inductor, capacitor? Weber? Okay. How much farad? 2 by 9 farad. What about this one? By looking at this, you can see that it's parallel combination of L and C, which will be in series with rest of the impedances, right? Just you have to write down the values. I'm not writing, maybe Aman will draw that, right? Do you need more time, Aman? Okay. So last time you already did this. That's why I'm asking you. Yes, Vaishali, are you following or any problem? Yes, sitting that. So you got all the answers. Can you draw here? You got. Okay. You're faster than Amar. So I'm redrawing what Vaishali has drawn. So where this one is connected, we are taking back. Right? What are the values? 2 Henry, 2 by 9 farad. What about this? 2 by 15 Henry, 15 by 8 farad. Is it correct or? Yeah, you can sit down. Thank you. Is it correct or can you tell me the correct answer? What's your name, by the way? Divyanshu. Can you tell me the correct answer? Capacitor is 2 by 15 farad and this one 15 by 2 Henry. 15 by 8. Okay. So here it becomes 1 by 2 by 15 times S plus 8 by 15 times S. So when we are writing 1 divided by, this becomes admittance, where this value will give me capacitor, this value will give me inductor, right? This is a common mistake people are making. Last time also, I don't know, you are here in last lecture. Yeah. So people makes mistake here. So whenever you are looking at this function, you should convert it to impedance or admittance so that you will get the correct answer, right? This is a common mistake people are making. Even if you are giving some competitive exam where ABCD is given to you, you will find wrong answer also part of your ABCD. So you will get confused. So always follow admittance, impedance, right? So if you are following this is the final answer. Now I'm asking you to design Foster 2. When I'm asking Foster 2, it's Foster shunt or parallel technique, where all the things will be at in parallel. If we are writing the function, if we are writing the function, so somebody can volunteer to draw this one, and you have to find the values also. Nikita, do you want to try this one? I'll help you. Don't worry. You have to draw the circuit for this. For a given admittance, you have to draw the circuit, right? Dinesh, can we have some white chalks? Can you check in A13? Nikita, can you try here? It's not visible to me. Otherwise, I'll not help you. Okay. Okay. So before drawing anything, Nikita. So this is admittance function. Admittance function will give this one as capacitor. But if you are saying addition, what is the meaning of addition? All the okay. Okay. So please use that. Can you give it to her? Nikita, you can use white color. You people also can try on your notebook. This is a capacitor. If this one is shunt combination in admittance, it has to be series LC, right, in admittance, similar to this one. And this one is inductor. Okay, 1 by K, 2 divided by square. Is this answer correct or not? Okay. So just you have to make sure that which side is input and which side is out, or it has to be from here to here. If you are looking into this, this will be y of s. You can draw same thing as follows. You can make this way also. Both are same, right? Thank you. So it will go as follows, right? Right. So now I want to find out. So this is the question given to you. You have to find out following things. So still numerator is higher than denominator. So it will give you some k0 times s plus k2s divided by s square plus 1 plus k3s divided by s square plus 3. So you have to find out k0, k2 and k3. K0s is nothing but pole at infinity. This is pole at -1, double pole are there, and this is s square equal -3. By the way, this technique is faster than your technique, or still if you think that your partial fraction method is fine, then you can do that one also. I don't have any problem. Previous method without without using Cauchy's theorem. Yeah, Mahima, are you following or? So what is K0? Mahima, what is K0? Okay, you are calculating in your brain. Okay. Yeah. Hmm. Yeah, so that is what I'm saying. Foster 2 technique is applicable for y of s. If z of s is given to you, you have to replace that with y of s. Let's assume that I want to synthesize this one using Foster 1, right? So Foster 1 technique is Foster series, and it's applicable, or it's advisable to use z of s only. So then you can write down y of s is equal to 1 by z of s, right? Which is equal to s square plus 1, s square plus 3 divided by s square plus 2, s square plus 4. So now can you synthesize z of s? Yes, that if I want to find out Foster 1 is applicable to z of s. You have only two possibilities. Either like you will have admittance function or impedance function. If admittance is given to you and you have to find out Foster 1, then just make 1 by z of s, right? Yeah, Piyush, all good till now? So what is K0? 1, somebody told 1, K2, hmm? 3 by 2, K3, 1 by 2. All entries are positive. It has to be positive. If they are not, then you are making some mistake, right? So you can see what 0? 0, because numerator has higher order than denominator. One order is higher. That's why we are keeping K0 as. If denominator has higher order, then you have to keep K0 divided by S plus rest of the things. Anybody who wants to try this circuit? because illustration, like completion of illustration 2 means Foster 1 and Foster 2 we are not looking back, right? Then we are going to solve coir 1 and coir 2. Then it's completion of LC impedance function. Thereafter we are going to RC and RL. So still if you have doubt, please ask me. Yeah. Any doubt? Can you help me in drawing this one? So you can come here and can you draw this? So this one is not visible, is it? Like you have some power in your eyes. Okay. You can do one thing. You can go back and you can see that that one. Yeah. Can you draw? Now you can see, right? But you are following the lecture, right? It's here. White is here. Okay. So there are 3 different entries. They have to be in series or in parallel. So all these entries will be in series or in parallel? Parallel. Why do you think it's in parallel? Hmm? Yeah, so it's admittance. So all plus entries are in shunt, right? So this is y1, this is y2, and third one is y3. So what is y1? Y1 is, so let's not give into him. What's his name? Sorry. Dhruv. Okay, Dhruv. If you need any help from my side, I can help. Is it easy or difficult? This one is. Similar questions I asked yesterday in the PhD's comprehensive exam, and people were not able to make this. When the things are asked like from top, like you have to find out whether it's LC function, RC or RL, and then you have to solve this. Then it might be difficult. Hmm? Then you have to find out whether it's LC function, RC function, or RL function, and you have to check all the properties. So properties of LC says that it has to be even by odd or odd by even. All the poles and zero has to be interlaced, and of course poles and zeros has to be left up plane, right? And they have to be simple. If that is the case, then it's LC. But if you are seeing somewhere real part, there might be resistive part will be there, so you have to synthesize that with RC or RL or RLC. Right? So you have to check the property. So in your examination, I am not going to tell you that this is the LC function. Please implement using Foster 1. This is not I am going to tell you. Right? Question ऐसे ही है. So I'll tell you not illustration. Maybe I'll give you some circuit to synthesize, or I'll give you some problem where you have to find out even this transfer function. Right? You have to design this transfer function. Like I asked a question which looks like this one. You have to find out values. That is more important thing.
S2S.
Not as to as I don't understand this, right?
वापस दोबारा देखना पड़ेगा सर.
So देखो दोबारा देखो 3 बार देखो. Who is stopping you? If you need some help, like your friends can help you. Who is your best friend? Who is your best friend?
कर लूँगा सर.
Okay. So this was the question I asked. X of omega with respect to omega is given to you. You have to synthesize this. This was the question. So there is a pole at origin. Pole at origin, not zero at origin. Pole at origin. Yes, so transfer function is as follows. Oh, sorry. These has to be zeros because it gives the value 0. That's how reactance curve works. Reactance curve works like if you draw the reactance curve from this function, it will give this value. S square. So you are absent maybe. If I am not wrong, you are absent in one of the lectures. Maybe in the reactance curve. You can go through video lectures. It's so much complicated. Just through.
So 1 by 6, 1 by 2.
I don't know, like 1 by 6. Like Pius is saying no. Huh? I don't know. Look, they are the examiners, so they have to see.
So it's क्या है?
Okay.
1 by 2 ये है, 1 by 6 ये है.
Do not listen to them. Look at the transfer function and you derive yourself. Yeah. So Dhruv. So is it capacitor or inductor? You can see same thing in TV. Yeah. It's capacitor with value of 1. Right? So capacitor with 1 farad. This one is, if I am rewrite this, it's equal to 1 by 2s plus
6 by s.
6 by s. So this is an admittance function. So 1 by admittance function becomes impedance. So let's forget about the numerator. Two functions, impedance functions are are used with plus, then it's in series. So they are in series. Just you have to find out which one is capacitor, which one is inductor. First part is inductor or capacitor?
Capacitor.
No, inductor. In impedance,
Sorry.
S times L is inductor and S 1 by SC, this is capacitor. So tell me the value. 2 Henry. 2 Henry. Look at this. S times L. So L is 2. What about this one?
So 6.
Not 6. 1 by 6. Look. So now try last one. Try last one. Okay. Hey, last one. Ho jayega. Next time Dhruv will come and continue with choir 1, choir 2.
2s.
Okay. Correct or wrong? Okay.
So 2 by 3 and 3 by 2.
Do not ask me. Like they will tell you. Pius, is it correct or wrong? Okay. Correct? Okay. Okay. So next time again I'll call you. Okay. So I believe there is no problem in Foster 1 and Foster 2. Foster 1, summarizing Foster 1. Foster 1 is also known as Foster series technique, and this is applicable to impedance function. And when it's LC, it follows 3 properties. Those properties are LC, CL are same in our function. In LC, you will have more number of zeros. In CL, you will have more number of poles. Right? The first element will be either inductor or capacitor. That will be decided by LC or CL. But both are same. LC or CL both are same. So first says that all the poles and zero has to be left half plane and they have to be simple. When I am saying simple, they have to be on j omega axis. They have to be interlaced. And third one, even by odd or odd by even entries has to be there, right? Interlaced. So if you look at this, that's why I told you you are absent in some of the lecture. So zero at origin, zeros are as follows: zero, if I draw them, this is called interlaced. 1 0 1 pole, 1 0 1 pole, and same this side also. So if it is not that, then this function cannot be realized with any technique of LC. Those techniques are Foster 1, Foster 2, Coir 1, Coir 2. So that is the meaning of this, right? So you have to check all the functions, right? So everybody got this answer? It has to be. So this book has one small mistake. You have to keep all the units which are coming from some scientist's name. They have to be in capital, right? As per SI units. So we are following SI units. So they have to be in capital. Okay. Now, do you want me to solve this Coir 1? Coir 1 is the technique which is not going to use partial fraction. It's going to use different technique which is called continued fraction expansion. So that is very easy. Can you divide this? Like somebody can volunteer and then we'll go today and next time we'll solve Coir and Coir 2. Somebody can divide this. Yeah. What's your name? Sohan. Sohan, can you solve this? So you have to do this one. No, not there. Here. You can also take help from your friends. Dhruv also can help you if you want. So what will be the first entry? Let him try. 12s cube plus 16s. If you remember, this is coming from the property called Hurwitz, right? Where we are dividing even function with odd. So you can see the numerator has all the odd functions and denominator has all even entries. Or you will have reverse of that, and that's how LC transform function is formed. It has to be either even divided by odd or odd divided by even. So in this case, it's odd divided by even. No, not. You have to reach till 0. So this side it's 2s. So 2s.
It won't be divided.
Look, it has to be 2s5. First entry, when it's multiplied with s raised to 4, it's 2s raised to 5 plus 8s cube plus 6s. So this is 4s cube plus 10s. So this entry will come here. You have to keep here s4 plus 4s square plus 3. When you are dividing, this So what will be the next entry? Yeah, we keep that. हाँ बहुत लंबा होता है but yeah you have to solve it. There is no other way. So it's 1 by 4 times s. So it's s raised to 4 plus 10 by 4. So again, this is not 0. So take this one, keep it here. Right? So you have to manage it. Okay. Is there anybody who has problem here to solving this? Okay. So how to realize the coir 1 circuit using this continued fraction expansor? We'll like do it on Thursday. And Saturday, please fix the time so that we can meet. Saturday, do you have any lecture? In morning you have some lecture, right? Mahima? Saturday? Hostel day, so I don't know. You have to tell me. Okay, Sunday. Sunday, no problem. So laboratory session will be there. So we have to meet in PC lab. We are going to do some small experiments on spice, so that I can give you project to make something on spice. Right? Yeah, done. Thank you. I'm asking you. Look, when do you want to have like Sunday को क्या है? Today evening, like it will be back to back many lectures for me because afterwards I have 1.5 hour, one more lecture is there after this. If you can come to North, no problem. I live in North.